Hello everyone, this is Mr. Slomka. Welcome to 3D Figures. Today what I wanted to do is I wanted to talk to you about the volume of cylinders, cones, and spheres. So we've talked about the cylinders, cones, and spheres before, but last time we had done surface area, so we're going to be talking about volume today. Volume is going to be the number of cubed units contained on the interior of a solid. So let's say you'd bought yourself a brand new cup. The volume of that cup would be the amount of water that you could use to fill that cup up. So not the packaging on the outside, but the water that would go on the inside. In general, like we've seen before, volume is basically the area of a base, and you're going to multiply that by the height. So this is a really, really good formula because it works for all the different kinds of shapes. It works for cylinders and cones and spheres, but it also works for prisms and pyramids, and so keep that formula in mind. Let's get a little bit more specific though. So here's our three basic formulas that we're going to be focusing on today. All of our formulas are going to be using circular bases, which is going to be the theme that's going to tie them all together. So our first one is a cylinder, and it actually has two circular bases. In general, though, when you're calculating your volume, you just need to know the area of one of those bases and multiply it by the height. If we want to get more specific, because it is a circle, you can get the area of that circle by using pi r squared, and then you'll multiply that by the height to give you the entire volume. Now a cone is a little bit smaller. If you take a look at what I've done here is I've drawn a cylinder over top of my cone. But if you notice, we are not using this portion to the left or this portion to the right. So that is why it is not simply the area of the base times the height, because there's extra that we need to remove. So we're going to be using 1/3 the area of the base times the height, or 1/3 pi r squared times h. Now sphere. Sphere is a little bit interesting right here. So we're going to be using this special fraction right here, which is 4/3. Then we're going to use pi r cubed. So now this one's a little bit interesting right here because it is cubed. We've been doing a lot of squares here, and so this is the one that is a bit strange because it is in fact cubed. So make sure you're watching out for that one right there. Okay, let's try a couple of example problems. So my first example that I have for you right here is this cone. And so now this cone, I've specifically turned it on its side, and I think that that's important. I also want you to notice that I haven't given you the most clear information. Basically, for a cone, the info that we need to know what the radius of the base is, and we need to know what the height is. And I'll be honest with you, I've given you neither of those things, which is frustrating. So let's take a look at some of the information I have given to you. So this distance that I've given to you right here is 14 yards, and that is not a radius, but rather a diameter. So that diameter right there is helpful, but it is certainly not exactly what we're after. In order to get from diameter down to radius, you need to simply cut this in half. So our radius was not given to us, but it is easy to come up with. It's going to be 7. Now the height of the cone is another interesting thing. Now this is the reason why I turned the picture on its side. A lot of people might say, well, the height is then 14 because that's going from the bottom to the top. In that case, no. When you're talking about height, remember that you're always starting from a base and you need to be traveling perpendicular. So this 90-degree angle right here on our base is going to instigate the fact that this right here is our height. So I need to know what that distance is, and I don't. What I am given, though, is this little 32-degree angle, and that's my hint. That 32-degree angle is going to tie in with that 90-degree angle, and it's going to tie in with that radius of 7 that we had earlier. And what we're starting to do right here is we're starting to build ourselves a small right triangle, and because it's a right triangle, we can use some of our great right triangle tricks, like SOHCAHTOA. So SOHCAHTOA works great to help us find missing side links, as long as you know what kinds of sides we have. With respect to that 32-degree angle, 7 is an opposite side. And this h height that we're after is going to be an adjacent side. So we want to use the choice right here that has the O for opposite and the A for adjacent. That's going to be tangent. Whenever you're making one of these choices, it's always the tangent of an angle. So we'll do tangent of 32. We're going to set it up with our fraction, with our opposite first and our adjacent second. So it's going to be 7 over h. I'm going to choose to write my tangent over 1, and then I'm going to multiply on the diagonal. Now in this case right here, what's going to end up happening is we're going to get a pretty nasty answer. It's not going to work out very nicely for us. And so we're going to have to do some decimal rounding, and that's okay. So I've multiplied on my two diagonals, and I've got my h right here. There's no more fractions, but the h is not alone. So I'm going to do a little bit more dividing. I'm going to divide by the tangent of 32 on both sides. Now this guy right here is definitely what I'm going to type into my calculator, 7 divided by the tangent of 32. And I'm going to end up with 11.20 for my height. I can't get a nice exact value for that one, so I'm pretty much just stuck with what I've got. Super. Okay, so now that I know what my radius is, 7, and I know what my height is, I have everything that I need in order to calculate the volume. So let's go back up to our formula. Once again, our formula is 1/3 pi r squared times height. So let's fill that in. So our volume right here is going to still be 1/3 pi r squared times height. And we're going to fill in all the numbers that we need for this problem. So our radius is once again 7, so we'll put our 7 in there. And then our height is once again 11.20. Now you can type all of this into your calculator all at once. It's all multiplication, and so it will work very, very nicely, and you don't have to spend a lot of time typing in pieces individually. As I stated earlier, we had a pretty ugly decimal, so we won't be able to get very good exact values for this problem, and so we're just going to round it, and that's okay. When you're working on these problems, sometimes you need to round and get yourself a decimal answer, and sometimes you can get yourself a nice exact value. So this is my decimal answer right here. There is going to be units on this, so we want to make sure we go back to our problem and take a look at the units. And so right here, this diameter that I gave you was in yards, so we want to make sure that we got yards on our final answer as well, and we want to make sure that they are cubed, because this is volume. So our final answer for this guy right here is going to be 574.70 yards cubed. Next one. Next one is a cylinder, and this one's far more straightforward. So what I'd like you to do is I'd like you to try this one on your own. Pause the video, and I'll share my answer with you in a couple of moments. Here's the answer for you right here. What we have is we have a radius of 5 that is given to you and a height of 6 which is given to you. We're going to use pi r squared for our base, and then we're going to multiply it by the height, which is going to be 6. Now when I'm doing this one, I want you to take a close look right here. Because these numbers are so nice and clean, I can get myself an exact value. I'm just going to be focusing on the 5 squared and the 6, and then when I do that, I'm just going to write my answer with the pi. So I could get a decimal by multiplying my 150 times pi, but in this case, I'd like to try to keep it exact. So now what we've done is we've seen two different kinds of answers, some that are rounded and some that are exact. Both of them are valid and both of them have their place, and so we want to make sure that we can practice both of those skills. Let's move on to the back side. So on the back side, what we have is we've got a bit of a backwards problem, which I always enjoy. So we have a problem where I'm going to give you a volume, which is right here, 1,253, and I'm going to ask you about a specific unknown, and in this case, it is the radius. So we're going to try our very best to use the exact same volume formula, and we're just going to plug things in as best we can. So now our volume that we have right here is going to go in for our capital letter V right there. So we're going to put our 1,253 over here on the left side. Then we're going to have our pi, and our radius is our unknown. So we're going to use our x right there that was mentioned on the drawing. And then our height is given to us, and it happens to be 10. Okay, so now after that, what we need to do is we just need to see if we can solve for the missing variable, which is going to be that x right there. So I'm going to be dividing to get rid of these things right here. So we are going to divide to get rid of the pi, and we're also going to divide to get rid of the 10. So we're going to divide on the left side and on the right side. Okay, so now when we do our division right here, we're going to get a much smaller value. When you take this 1,253 and you divide it by this large product right here, you're going to end up with 39.88. And that is now going to be equal to x squared. Now it is x squared right here, which is not perfect. We just want x. So that means we do need to take this one step further. We're going to square root the left side and square root the right side. And when you do the square root, you're going to get a small radius, which is what you're supposed to. In the picture, it looks like our radius is a little bit less than the height, so I'm looking for a number that's close to 10, but certainly not 10. So I'm going to do my square root, and I'm going to get 6.32. That seems very reasonable, and I like my answer. Now, just like in the last couple problems, units are important, so we want to make sure that we put the proper unit. I noticed that for these guys right here, the units seem to be centimeters. Now, in the last couple problems, we did put cubes on our units right here, but remember, in this problem, we're not actually finding a volume. If you look, they did put their cube on their volume measurement right there, but we're just finding a radius. So we do not want to put a cube on this guy right here. We're going to leave it just like that, and we'll be all done. All right, let's talk about some stranger shapes. So now what I have for you next right here is we've got some shapes that are going to be a little bit more crooked or oblique. And so what I've got is a cone, and instead of having the point directly over the center of its base center, it's going to be off to one side. So we have this great principle right here, which is going to state that if you have two solids that have the same height, and their cross-sectional areas is going to be the same area every time, then that means they're going to share a volume. Now, this doesn't really seem to be related to our picture, but let me show you what I mean. What I mean is, if I had another cone that lived right next to this one that I have already drawn, but it was nice and vertical and straight up and down, what we would see is they would have the same base down here at the bottom. And if I took a cut from any particular height, I would end up with the same size circle each time. And I could do that at the bottom or at the top or in the middle, and it would work out the same. Which means that if I filled this cone up with water and this cone up with water, it would take the same amount. So it doesn't matter that the cone is crooked or oblique, because the volume will not change. So this guy right here and this guy right here are going to be the same, even though this one might be a little bit more perfect looking and this one's a little bit less perfect looking. So we're still going to use the same volume formula. We don't have to change anything. We just need to make sure that we have the actual vertical height that is perpendicular to the base. So I'm going to start off with my radius, which is right here, 4.5. And then I'm going to use the height, and the height right here is 12. So that's not a diagonal value right there. It's not a slant height. It's just a regular height. And so I'm going to be able to use it without too much effort. And so this is going to give us the volume of the nice, clean, straight up and down cone, and it's also going to give us the volume of this more crooked, diagonal, oblique cone. So when we do our calculations this time, once again, just type it all into your calculator all at once. I would give you a pro tip of using some parentheses because they will definitely help. I'm going to focus on these parts and the 1/3, and I'm going to ignore the pi. So if I do that work right there, if I just do 1/3 times 4.5 squared times 12, I'm going to get 81. And like I said, I'm going to ignore the pi, and I'm just going to leave him for later, so we're going to have our volume looking like that right there. We still want to use our units. Our units right here are feet, so we're going to put our feet right there, and this is a volume, so it's going to be cubed. So we're going to end up with this answer right there. That's another exact answer. So now on the back side, we've seen some rounded answers again, and we've seen some exact values as well. All right, for my very last example that I have for you, I have this guy, which is a composite solid. Composite means it's made up of more than one shape. So what we have right here is we have a really cool shape. This is a cylinder, and then what we've done is we've basically scooped down into the cylinder, and we've pulled out this hemisphere, or half of a sphere, shape, and so it's got this little cup on top that you could, I don't know, put a golf ball or a ping pong ball on or something like that. And so that guy right there is a fun little shape that we have created for you that's got this scoop out of it. So in order to get the volume, what we're going to need to do is we're going to need to break it down into the two different shapes, and that is what I have right here. I have one cylinder, and then I have my hemisphere that I've kind of drawn right there. The way that it has been created with this scooping out is means that I'm going to need to use subtraction. If the hemisphere had been added on to the top, I would have used addition, but since it's been scooped out, I'm going to use subtraction. Now the formulas are exactly the same. So for a cylinder, it's going to be pi r squared times h. And for a hemisphere, we are going to use our sphere formula, which is going to be 4/3 pi r cubed. But this is not a full sphere. It's only half of one. So that means I'm going to incorporate an extra 1/2 as well. So now it's going to be 1/2 times 4/3 times pi times r cubed. So that formula is a little bit extra complicated. Okay, let's plug in some information. So for my first one, the cylinder, it's very straightforward. I just need the radius, which is given, and the height, which is given. So we're going to plug in our pieces with our 3 being squared and then multiplying by our 5 after that. Okay, now for the sphere, it is actually going to reuse a lot of the same information again. So the only one you really need for the sphere is the radius. And since this hemisphere lines up perfectly with the sides of our cylinder, it's going to share the same radius of 3. Even though the 3 is down here at the very bottom, it's going to work up here at the very top in the same type of way. So we are going to use our 3, and it is going to be to the 3rd power. Okay, all of this is a bunch of multiplication, which means that we can multiply them. I am going to once again try to get an exact value, and I'm just going to kind of work around my pi's. So I'm going to do 3 squared times 5. 3 squared is 9, and 9 times 5 is 45. I do have my pi still, so I'll keep my pi there. All right, so now the next one, 1/2 times 4/3. That's actually going to be the fraction 4/6. And then what you can do is you can take that and multiply it by 3 to the 3rd, which is going to be your 27. And so that is going to give you 18. And I've worked my way around the pi. I haven't actually used the pi, so I'm going to just toss it on there at the back. Okay, so now if you had 45 pi's and we took away 18 of your pi's, how many pi's would you have? We're going to keep the pi, and we're going to change the number. 45 take away 18 is going to be 27 pies. Let's talk about units. So for our units right here, we have inches showing up in both of these. So this is a volume, so it's going to be inches cubed. Okay, there you go. So there are your final answers. If you have any questions at all, please make sure you email your geometry teacher or attend their Zoom. I hope you have a great time. Thank you so much. Please move on to the worksheet.